All right, we're finally at the last video for this giant method machine packet. So we're going to finish this up today. So you're going to need this packet. You should have already filled up through example 9. So if you flip through, if any of this isn't filled in, make sure you watch the videos that correspond with those. But we're going to start with example 10. You'll also need the ASCII chart, which I gave you, or which you should have picked up for the last video. So find that if you don't have it. And once you have those two things, let's get ready with number 10. Number 10 says, define a method which will convert a digit character 0 through 9 to its numerical equivalent, also 0 through 9. Okay, so I mentioned a little bit in the last video that the characters 0 through 9, or the digits 0 through 9, are actually characters as well. They're shapes that mean those numbers. They also have an ASCII code number. 0 corresponds with 48, and then it goes up 149, 250, etc. So if I give you a character that's one of these values, 0 through 9, I want to make it into an integer that's its equivalent value as an integer, 0 through 9. This is actually a problem that's going to be pretty important for the next program that we do. So I'm going to just star this and write code check next to it, because when you get to that next program, which is called code check, make sure you go back and refer to this method. Okay, so it's going to convert a digit character, so that's our parameter. We're going to be given a digit character to its numerical equivalent, so it's going to return an integer. So that's why I made this a public int, and I just called it convert. And again, we're given a digit character. So I'm going to call it just char ch, like that. Okay, now if you look at the ASCII chart, 0 corresponds with 48, 1 corresponds with 49, etc. So I'm going to write that. The character 0 is the value 48. The character 1 is the value 49, etc. So remember, doing math to a character changes it into an integer. So if I just did, I can do this in one line. If I just say return the character that I'm given, so ch minus 48, that's going to take, so like if it's a 0, if ch is equal to the character 0, doing 0 minus 48 is as good as doing 48 minus 48. Because doing math thinks of the character as its ASCII number. So similarly, if character ch, if ch was equal to 1, the digit 1, it'd be 49 minus 48, which is 1 as an integer. And I don't need to cast it or anything like that, because remember, doing math, in this case subtraction, to a character makes it an integer. So it doesn't seem like much, and it might not even make a lot of sense to you right now, but that does what we're asking to do. Now, just as a side note, we could also just say or ch minus the character 0. If I do this, I don't really need to look at the ASCII chart. I don't need to know that this index is 48, because it's going to take whatever character I give it minus whatever value 0 has on the ASCII chart, which in this case is 48. All right, so that idea is going to be super important for the next program. So if you have questions on this, please pause the video, write a note, or call me over right now so I can answer it. But if you're good, here's number 11. Number 11 says, define a method which, given 2 integer parameters, returns a Boolean value that indicates whether the second integer is a factor of the first integer. Okay, so now let's talk about this and think about it for a second. Given 2 integer parameters, so we're going to, in our parameter list, we're going to have int first variable, int second variable, returns a Boolean value, so it's got to be a public Boolean, that indicates whether the second integer is a factor of the first integer. Another way to word this last part here would be to say whether the second integer evenly divides the first integer. So can you think about something we've done a bunch of in comp sci that checks about evenly dividing into another integer, how we could do that? I want you to try this on your own. So if you notice, there's 2 spots here. because there's two ways to do it. Last time in the last video, I showed you a public Boolean. I showed you could do it in one step because the answer to an if statement is a true or false. If that makes sense to you, write that here. If you'd rather write the longer way with an if-else statement, if they are a factor, return true, otherwise return false, do that down here. But regardless, take 3 or 4 minutes, pause the video, and try to write it on your own. Go ahead. Okay, so if you're watching this part of the video, I'm assuming you've taken your time and have already tried it. Let's do the less desirable method first. I told you it'd be a public Boolean. So we can write public Boolean. And we got to name it something. I called mine factor. It doesn't really matter what you call it, as long as you have some name there. And it's given two integer parameters. So you have to say int, whatever the first variable you want to be called is. I just called it first. And int second, whatever the second variable called. So you can call those whatever you want. It doesn't have to say first and second, but it does need to say int here and int there. All right, so we want to check if the second number is a factor of the first. So in other words, if I take the first number and divide it by the second number, is there no remainder? That's mod. So I could say if first mod second equals 0. In that case, we're going to return true. Otherwise, so else, we're going to return false. That's it. So either it is a factor or it isn't a factor. All right, so now let's go back to that faster way. If you do it the other way, you still need to have the exact same method header. So it's still going to say public Boolean factor. And we still need to have two integer parameters. So you're still going to see int first, comma, int second. But again, this is the answer we're looking for. If this is true, we return true. If it's false, we return false. So I might as well just return what this statement says. We can return first mod second equals 0. That's it. Again, if this doesn't make sense to you, it'd be a good idea to call me over and have that me explain that to you. But you can do that one line of code in what all of these lines of code accomplish. Okay. Ready to go on? If you want me to check your individual one that you tried, if it doesn't exactly match, call me over and I'll let you know if it works or not. But let's go on to the next page. Okay, so example 12, define a method which returns the factorial of a non-negative number, integer. So I don't know if you've seen factorial before, but that's this exclamation point. So 5 factorial means you start with 5, and then you multiply by one number less every time until you get to 1. And your answer is one value. So like if I gave you 3 factorial, what would that be? Well, you'd start at 3, then you'd multiply by 2 times 1. Once we're at 1, we stop. 3 factorial would be equal to 6. Okay, so now there's a couple qualifications here. It has to be of a non-negative integer. So the value that's given to you, this int num parameter, has to be a non-negative integer. I could guard against that in the code, but we're going to do something instead that's going to make me not have to worry about that anymore. I'm going to write up at the top some notes before we do this. We're going to do something called pre and post conditions from here on out. So now include pre and post conditions. when writing comments. So the old way of you writing one comment for every method is totally done now. Anytime you make a method, you're going to have a precondition and you're going to have a postcondition. The precondition describes what the parameters are. So what's being sent in, essentially. In this case, it's going to be describing int num. And I'm intending num to be a non-negative integer. So if I'm using this program and I send it a non-negative integer, this will work correctly. That's what the precondition is going to say. The postcondition is basically what your old method up to this point has been. You're just going to describe what the method does or what it returns. Okay, so every single method that you write from here on out needs to have this pre and post. If there's no parameters, so you're sending over nothing, then the precondition is just none. The postcondition will never be none, even if it's a public void, because you can still describe what the method's doing, just like you did before. The only way the postcondition would ever be none is if you literally had nothing in the method, which you won't ever have. Okay, so for this particular method, factorial, our precondition is supposed to describe num. So a precondition is going to be a non-negative integer. And then, like I said, the postcondition is going to do what we've been saying all along. So in this condition, the postcondition would just be returns the factorial of num. Okay. Now what that helps me do is now if I'm a coder, if I come and read what this method is supposed to do, I can read that I'm supposed to send it a non-negative integer. So this code's not going to guard against me sending something other than a non-negative integer. That way it's user error if it doesn't work and not the coding error. So think about how this is going to do this. We're going to start at this value. We're going to go all the way down until I get to 1, multiplying as I go. So what two things do you think I'm going to need? Well, if I'm going to keep multiplying on, I definitely need an accumulator. So let's just call it int product. And if I'm multiplying onto an accumulator, what should I set it equal to? Not 0 this time, because if I multiply something onto 0, it's going to stay 0. If I want to multiply onto something, I want to start it at 1. That way, if I multiply it by 5, it gives me 5. Okay, now what can I use that's going to start me at num, and I can just go all the way down, keep running until it's equal to 1. Hopefully you're thinking a for loop here. So we're going to have for. If I want to start up at the number that's given to me, what would you want I to equal? Well, the number given is num, so I want I to equal num. I'm going down to 1, so I want I to be greater than or equal to 1. And I'm going down, so I need I minus minus, right? Okay, now everything along the way is supposed to be multiplying on. Each time I want to multiply on whatever value I'm at. So we're going to have product times equals what? Well, I is keeping track of what number I'm at. That's what I want to multiply on. So times equals I. That's going to get me the factorial. So then my final step will be, and the final step is return product. There we go. Any questions? Hopefully not. If there are, call me over. All right, number 13, a little trickier. Define a method which returns the letter of the alphabet, an uppercase letter, which is the fifth letter beyond a given letter, also uppercase. If the fifth letter is beyond the end of the alphabet, then keep counting from the beginning of the alphabet. So it's cyclic. So what that last part means there is, well, let's start easy. If I have A, what's 5 letters later? Count. One is B, 2 is C, 3 is D, 4 is E, 5 letters later would be F. That's easy. But if I have a letter like Z, they want me to cycle back. So if I cycle back, 1 would be A, 2 would be B, 3 would be C, 4 would be D, and 5 would be E. So Z is going to go to E. Similarly, Y would go Z, A, B, C. X would go Y, Z, A, B. Oops, sorry, that last one should have been D. Alphabet's tricky. I'm a math teacher. Y, Z, A, B, C. Before X is W. So if you count 5, X, Y, Z, A, B. And then before that is V. W, X, Y, Z would be A. Those are the ones that are going to have to cycle around. That's what this means. Okay, so think about what type of method this would be. This would be a public what? Well, it's returning a letter, so it's a public char. And you can call it whatever you want. I called mine letter, which is the fifth letter beyond a given letter, so it's also given a letter, so the parameter is also a char. Char CH, we'll call it. Okay. Remember, we're doing pre and post conditions now, so that'd be my next step. My precondition, is there any restrictions on what this character is? Well, it's supposed to be given an uppercase letter, so that's what I'm going to say. The precondition is an uppercase char. And the post condition describes what the method does. Returns the letter 5 letters past CH. Okay, so now essentially we have two cases here. We have the case where we don't have to cycle around, the easier case, and then we have the cycle around case. So since there's going to be a couple possibilities here, let's make a temp variable. I'm going to say char temp. Okay, next up, let's do the easy case. So if the character is a letter that comes before U in the alphabet, I can just add 5 to it and get to the letter that I need, because U is the one that comes before V. So remember, we can do math to characters. I can say if CH is less than or equal to U, U is a character, uppercase U in single quotes. And I didn't even need to look at the ASCII chart. Now, uppercase U is 85. So this is essentially saying if the character that's given to me has an ASCII value that's less than or equal to 85, then all I have to do is move 5 ahead. So like, for example, if I was given A, move 5 ahead, 1, 2, 3, 4, 5, I'm at F. But think about what that does mathematically with the numbers. Moving 5 ahead from 65 gets you to 70. So I'm essentially just adding 5 to whatever ASCII number I was at, and I get to the value that I need. So how that looks here is I can just say temp equals whatever CH was plus 5. You know, there's a small issue with that. Does anyone see it? What happens to CH when I add 5 to it? It becomes an int. So that quantity right there is an integer. Temp is supposed to still be a character. So it's changing it to its new ASCII number. I need to convert it back to its actual character. So you need to put char in quotes before that so that it casts it as a char again. Okay, so else, if it's one of those cyclic letters, what actually happens? Let's look at the ASCII chart for a second. What's Z on the ASCII chart? It's 90. So if I've got an ASCII value of 90 and I want to send it to E, what's E's ASCII value? 69. So to get from 90 to 69, what do I have to do? Well, that's a difference of 21. Let's check Y and D. Y has an ASCII value of 89. And D has an ASCII value of 68. What do you notice? Difference of 21 again. All of these are always going to be a difference of 21. And if you actually just counted back in the alphabet, from Z as the 26th letter to E, which is the 5th letter, there's also a difference of 21. It doesn't really matter what these ASCII numbers are. What matters is the difference is always 21 values. So if I just say else temp equals, cast as a char again, CH minus 21, that'll make it kind of look like it loops around. Now notice I didn't really need the ASCII chart for this at all. I could have figured out that Z went to E is a difference of 21 without looking at the ASCII numbers. I just showed you that so that it would kind of make sense both ways. By the way, I have in my notes that if you want to really know what ASCII stands for, it's American Standard Code Information Interchange. American Standard Code Information Interchange. So if that ever shows up on Jeopardy again, now you know. All right, let's go to example 14, next page. To find a method which returns a Boolean value that indicates whether the area of a rectangle equals the area of a square. The values sent to the method are the lengths of the sides of the rectangle, length and width, and the side of a square. So it's another one of those Boolean methods. You're either going to return true, that the area of the rectangle is equal to the area of the square, or false, if they're not equal. So think about how you calculate the area of a rectangle. Think about how you calculate the area of a square, and see if you can take a few minutes to write this. I've already written the method header for you. It's another one of those alternative but less desirable ones also, because we could do an if-else statement. If you want to start with that, start down here. If you think you can jump right to the one line of code way, do it right here. But also remember, don't forget you need pre and post conditions. So if you can pause the video again, take 3 or 4 minutes and see if you can write this. Go ahead. All right, so assuming you tried this, let's start with the more efficient method first this time. So first step, see how you wrote your pre and post conditions. Precondition is the length and width of a rectangle and the length of the side of a square. So I'm going to say 3 ints representing the length and width of a rectangle and the side of a square. Post condition. Now first, also, it's important that these descriptions go in order of what you're sending it, so the person who's using this code knows what order they need to send stuff. Post condition. Post condition returns true if the area of the rectangle equals the area of the square. Okay, so if you want me to read your pre and post conditions to see if I think they are acceptable, call me over. But the one line of code that you need, and the only line of code that you need here, is to just say return. How do you calculate the area of a rectangle? Length times width. We want to check if it's equal, so I need double equals. How would you check the area of a square given its side? Side times side. That's it. If that is the same, it'll return true. If it's not the same, it'll return false. Just so you have it down, the less desirable method, if you did it this way, I'm just going to write pre and post with an arrow up because it'd be the same as the pre and post I just wrote. I'm not going to rewrite those. But basically, you're just putting this in an if statement. So if length times width equals side times side, return true. Else, return false. All right, so hopefully you're getting used to the idea of how that's the same as that. But if, again, you'd like me to come over and check what you wrote, if it's any different, feel free to do that. If you're ready to go on, here is the last example. Finally, we're at the end of this giant packet. Example 15, define a method which returns the result of raising a number to a power. The number is a positive integer, and its power is a non-negative integer. So we're essentially writing math.pow. This is a little less useful than math.pow because the number has to be a positive integer, and its power has to be a non-negative integer. So that means it can be 0 or higher. So this can't deal with negative exponents. It can't deal with fractional exponents as math.pow can. So anything that this is going to give back is just a fairly straightforward exponent, which is why it's a public int. Okay, so when we write our precondition, we've got to talk about those restrictions. The number, which is the base, is a positive integer. So the precondition I'm going to say an integer base. And I'm just going to say an integer base greater than 0 because that means positive, and a non-negative integer for the exponent. So, and a non-negative integer. So basically non-negative just lets you use 0, whereas positive doesn't allow that. Okay, post condition would just be that it returns the value of the base raised to the power. All right, so this is kind of similar to factorial. We're going to need something to keep track of multiplying on a certain amount of times, which is an accumulator. So I just said int temp. And since I'm going to be multiplying onto this accumulator, what do I want to initialize it to? 1. And I need something to keep track of how many times I've done it. If the exponent is 5, I want to multiply it by the base 5 times. If the exponent is 7, I want to multiply it by the base 7 times. If the exponent is 0, I want to multiply it by it never. But what can I keep track that would count how many times I'm doing something? Again, it's a for loop. And this time I don't need the for loop to keep track of what number I'm multiplying. I need to keep track of how many times I'm multiplying it. So this for loop is essentially just used to count how many times I'm doing it. So we can start with I equals 1. I want to run it however many times exponent is. So I is less than or equal to exponent. I plus plus. And we're multiplying on to temp. So I definitely need temp times equals, but I would need times equals what? Well, what are you multiplying every time? Not I this time, because that would give you 1 times 2 times 3 times 4 times 5. I'm always multiplying 2, which is stored in the variable base. I just need temp times equals base. And my final line, once I've calculated it, we need to return temp. And that's finally the end of the packet. Okay, so I know that was a lot. That was a lot of information, a lot of examples though. So I'm hoping you have some sort of good feelings towards these non-Boyd methods, because the next program you write, which I mentioned earlier is called Code Check, is going to involve you writing some of these. Okay, so keep these packets, or keep this packet, and in the next video, I'll let you know what this next program is about.